Now let's talk about what is linear regression. So at first, the regression is the can be said to be it is the statistical relation between dependent variables. So when x and y are codependent with each other or they're dependent, so then we can use regression. So let's say house prices. So it is certain places there will be high prices for the house, in certain places the prices of the house will be low. So and it also included the size of the house. So if it is a higher square feet house, it will be have a higher price. It will be a low square feet house, it will be having a lower prices. So these are dependent variables. So to do prediction on these variables, we can use linear regression. Linear regression is a form of by keeping the price on a xy graph. So the prices are on x and the size of the house on the y. So if we plot our test predictions, test training values on the linear graph. So a smaller house is having a price of 20 lakhs, a bigger house is having a price of 80 lakhs. So if we take a house which size is a middle between these two, so by plotting a graph between these two variables as the price and the size, so we can get a points for the small house and bigger house by drawing a line which connects a linear line which connects the 2 points. We can get a estimated prediction by joining a medium size. By if the size of the house is let's say the smaller one size is a 20 and a bigger one size is a 60, so our medium size is having a size of 45. So by on the y-axis it will be 45. By extending the line from the y-axis parallelly to the x-axis, where the line meets the linear line which connect the both small house and the big house point, where it connected, we draw perpendicular line, and down we can get a certain price for that house. So the value we predicted is based on the previous training values. So we plotted the training values on our graph to get a perfect linear regression line. So with that line we can easily get the price, we can easily predict the prices of the remaining houses. So the increase in the number of training cases will make our line a perfect graph, so we can get the perfect prediction. So the computer doesn't know which line is perfect, so it will draw a line in a random ways. So here we use gradient descent. So at first it will draw a line in a certain way. If we calculate the distance between the already plotted points like small house point and large house point, we'll get those distances, and we'll move the line either towards the point or away from the point. So while it going towards the point, the distance between the points and our linear line is decreasing. So as I said in the gradient descent, we are going in a step-by-step format. So at first we are seeing we are moving the line away from our points. It is causing our distance between the points to increase. So that step is wrong. So we are going to backward and we are going closer to the points. When it's going closer to the points, we see that the distance is decreasing from the point to the line. So we can say the line is getting some type of perfection that we wanted. So this step is correct. We are going to the next step. We are going to move the line further closer or further backward. So if we move it closer, whether the distance is increasing or decreasing. If the distance between the points and the line is decreasing, then our step is correct, then we'll go to the next step. If it is decreasing, then we'll go back as a next step. So this is a process of how gradient descent is used on a linear regression. and this is the process of linear regression. Regression is nothing but the statistical representation of the dependent variables. So here we seen that the how price and size of the house are dependent. So in these type of prediction models, we use this algorithm to get better accuracy.